In the 1960s, if an enterprise needed to process data, they went to IBM. Mainframes were massive, expensive, and kept behind glass. But as business data requirements grew, a gap emerged. Organizations needed machines they could actually afford and deploy without retrofitting an entire building. Digital equipment corporations saw that gap. They built a new tier of hardware to fill it, the mini-computer. Look at the design of the PDP-8. It was a data processor engineered to be highly accessible, complete with physical toggle switches and exposed vertical circuit boards that engineers could actually reach and modify. This design philosophy carried into the PDP-11. It became the machine that hosted the first versions of Unix and early relational software like Oracle version 1.0, proving that a computer didn't need a basement-sized cooling system to run complex queries. By decentralizing the hardware, DEC allowed the database to move from a custom-built mainframe experiment to a commercially available software product that a single department could manage. By the mid-1980s, the gold standard for running an Oracle database was DEC's VAX 780 system, running the VMS operating system. Developers favored it because of its extreme stability. At the time, enterprise computing had a fatal flaw. If a single physical server failed, the database went down with it, taking the entire business offline in an instant. This blueprint illustrates DEC's solution. They connected multiple server nodes via a high-speed central interconnect into a virtual system called a VAXcluster. If one node crashed, the database survived. Processing load and shared storage instantly shifted to the remaining nodes without interrupting the user. To make that handoff work without corrupting the data, DEC engineered distributed lock managers. This is the exact same software logic that coordinates modern scaling today. For mission-critical applications, VAX provided a blueprint for system survival that modern cloud providers still follow. Eventually, DEC engineers developed the Alpha architecture. This 64-bit processor utilized an addressing space so large it could map datasets that overwhelmed the 32-bit memory limits of competing systems. Alpha used a reduced instruction set computer, or RISC, design. By stripping out complex instructions, it processed simple commands with a cycle time that made contemporary Intel chips look like relics. This chart compares database throughput during the peak hardware wars of the 90s. Alpha significantly outpaced rivals like Spark, PA-RISC, and the early Pentium in database-specific benchmarks. High-end shops moved their most massive Oracle workloads to AlphaServers because the hardware could sustain transaction volumes that typically crashed other systems. DEC had set the industry ceiling for processing speed, but they reached that peak exactly as their business model began to crumble under immense external market pressures. In the 1990s, the market shifted rapidly. Cheap commodity PCs began claiming the low-end server market, while specialized Unix rivals pushed in from the top. Sun Microsystems emerged as a fierce competitor, aggressively targeting the high-end database administrators that DEC relied on for its core revenue. At the same time, Microsoft began dominating the enterprise software layer, increasingly isolating DEC's proprietary VMS operating system from the broader market. The financial pressure broke the company. In 1998, DEC was sold to Compaq, and shortly after, those assets were absorbed entirely by Hewlett-Packard. Database shops initiated a massive migration away from DEC hardware, moving their workloads to HP-UX and Windows servers. The mini-computer era was officially over. But the concepts DEC engineered never actually left the data center. They are the structural DNA of the modern cloud. The techniques they refined, 64-bit computing, virtual memory management, and distributed clustering, became the default standard for every major cloud provider. Place a 1980s VAXcluster diagram next to a modern cloud availability zone layout, and the architectural similarities are immediate. When spinning up Postgres or Aurora today, you rely on the exact replication pathways VAX engineers drew up 40 years ago. The corporate winners of the 1990s kept their names on the buildings, but underneath it all, the world's data is still running on the bones of the architecture built by Digital Equipment Corporation.